Okay, the final. All right, forgot to put a headset on. All right, so the final type of reaction here is double replacement. There'll be two types of these, just like single replacement, and for the same reasons actually. So anyway, so let's get started. So for these type of reactions, you take two ionic compounds that have been dissolved in water. So in the last single replacement, you just took one ionic compound dissolved in the water and added a metal to it. Now you're going to take two ionic compounds, put them together, and then you're going to mix them. And what you get is an interesting effect. So the original two solutions are clear, but when you mix them, what you get, the result is a cloudy substance. And if you let it sit for a while, the cloudy part will settle to the bottom and will be a solid powder that you can actually separate by filtering. This process is called precipitation. It's sort of like snow or rain. It looks like it's coming out of nowhere. It's raining powder. Okay, so it's precipitation, and we're gonna go over a few of these. Uh, these type of reactions. So this doesn't happen with just any two ionic compounds. Um, we're not going to go over which ones are particular for it. Okay, uh, but what makes these chemical reactions take place um, is a change of state, and that means the two liquids form a solid. So one thing you won't notice uh, is oxidation reduction, but so there'll be no gain or losing electrons that you'll be noticing, but actually there is. So this is kind of the idea of what happens here is that you have these two clear liquids, and they don't have to be, they could be like a green clear or red clear, okay? But you take the two clear liquids and mix them together, and then you'll get this cloudy stuff, and then eventually it'll sink to the bottom. And so this is what we call our precipitate. And what you can do is you can filter this out. You can just pour it through a filter, and then you can collect this. And this is a real powerful tool in terms of trying to get things out of solutions. Water treatment plants actually use this kind of reaction a lot. I had a fellow that I taught a few years ago that was worked at the Pickwell water treatment plant, and he said they did these types of reactions all the time to try to get out all the nasty stuff out of the water. So our goal for doing these double replacement reactions is we'll start with we'll be given our reactants, and then you're going to have to finish the word equation, then write the initial chemical equation just like you did before, and then balance it, and this time no oxidation reduction. So let's get to it. All right. So this reaction is going to relate to what often when people go in and they have something problem with their gut, and doctors want to figure out what's going on, and what they'll do is they'll give them some barium, barium nitrate, and the barium nitrate when they gets when they swallow it, it'll combine with the potassium, and they add potassium sulfate to it, and what it does is that the precipitate will sit in your gut, and then they could observe stuff through the x-rays and do a diagnosis. Okay, so let's write out the equation. Say barium nitrate plus potassium sulfate, and then all you do is you swap. So I kind of, in the last example I talked about some guy dancing with somebody else person. This one's like a square dance where the barium goes to the potassium, and the potassium goes to where the barium was. So do-si-do, swap your partners, do-si-do. Okay, so you get barium sulfate and potassium nitrate. Right now what we want to do is write out the chemical formula. So you got barium nitrate. Okay, it's Ba with 2 plus charge. Nitrate, NO3 minus. Okay, swap the charges. Crisscross, put 2 here and 1 here. And so you have barium nitrate. Okay, potassium sulfate. Potassium is K plus. SO4. 2 minus. Crisscross charges, put a 2 here. Here. Okay, you could leave in parentheses or not. Okay, barium sulfate. Barium is Ba2 plus. Sulfate is SO4, 2 minus. And since the charges are the same, don't have to crisscross. And then same thing with K plus, NO3 minus. They have the same charge, no cross. And so this is our initial chemical equation. Now what we want to do is balance. Okay, and what you're going to do is that you're going to start out with one of the negative ions. And always start out with the one that has the most. So I have 2 nitrates, and what I want to do is I want to put a 2 here. Okay, and then I have 2 Ks, so I put a 2 here. And then I have 1 sulfate over here, 1 sulfate over here. I'm fine. Okay, so the first step was to get 2 nitrates. Second step was to get 2 Ks. Okay, then fix my bariums. There you go. And then you're done. No more. You don't have to do anything else. Alright, so silver phosphide plus iron sulfate, so write those 2 I's out. And then swap them. So the silver goes where the iron was, and the iron goes where the silver is. So you get silver sulfate and iron phosphate. Okay, then you write out the chemical formulas. So silver phosphide is Ag, and it's plus charge. Phosphide 3 minus, so you crisscross charges 3 right there. Okay, iron sulfate, Fe 3 plus, SO4 2 minus, put 2 here and 3 here, crisscross charges, and you get that. Okay. Then silver sulfate, Ag. Those charges don't change. SO4, 2 minus. Okay, so it's Ag2, SO4. Then iron phosphide is Fe3 plus. Phosphide is Fe3 minus. Same charge, don't have to crisscross, so this is your initial to balance it. Okay, so I am going to start with the negative ion has the most negative charges. So I have 3 sulfates. So what I'm going to do, first thing to do is I'm going to get 3 sulfates. Okay, ding. Okay. All right, now I need 6 silvers. Okay, so I'm going to come over here and put 2 times 3 for 6. Okay, and then I'm going to count my irons. I have 2, and then I need to put a 2 over here. Okay. Alright, so let's show you how we do in my class. So I start with my negative ion has the most, there's most of them. So there's 3 sulfates here. There's only 1 of the phosphide. So first thing I want to do is I want to get three sulfates. So I put a 3 here. Okay, now I need 6. My second step, I need 6 AGs. 3 times 2. So I need to put a 2 here. Okay, 2 AG. All right. Next thing I need to do is I need to have 2. So the third step is get 2 P's. So 2 P's. So I come over here and put a 2. Whoops. So I got 2 P's. And now notice I got 2 FEs. And they're okay. Alright, so start out with my sulfates, fix them, put a 3 over here. Now I need to have 6 silvers, put a 2 in front of here. Now I have 2 phosphides, so I come over here and put a 2, and then I check my silvers and I have 2. There you go. So that's how I get my answer. So it's 2, 1, 3, 2. Alright, now there's another type of double replacement, just like a single replacement. And remember we took an ionic compound, replaced it with the acid. Well, we can do the same thing here. We'll take an acid, and we're going to combine it with a special type of ionic compound called a base. A base for now will be an ionic compound with a hydroxide. So it'll be a metal hydroxide, like sodium hydroxide or whatever, okay? Okay, this type of double replacement reaction is called acid-base neutralization reaction. So you're going to take an acid and a base, and then you're going to neutralize it. And it's going to form salt and water, which we'll talk about in a minute. So what drives this type of reaction is not forming a solid, but we form water. Okay, and there's 2 double replacement reactions: precipitation, which we just got done talking about, and now we're going to go through acid-base. So let's go through an example. So we're going to take hydrochloric acid, with sodium hydroxide. So acid plus base. So we're going to finish the word equation, but what we got to do is change this to the acid form. That'll help us out. Change this to hydrogen chloride plus sodium hydroxide, and then swap. So the hydrogen will go where the sodium was, and the sodium will go where the chloride. So you end up with hydrogen chloride will produce sodium chloride and hydrogen hydroxide. And if you write that out, it's HCl, NaOH gives me NaCl plus H plus OH minus. And if you know it, it's already balanced. Okay, but let's take a little closer look. Notice hydrogen hydroxide is HOH. And hopefully you recognize is that this is water. Okay, it has 2 H's and an O. So acid-base reaction forms water. But what we're not going to write as H2O, we're going to leave it as HOH. So the word equation is really hydrogen chloride plus sodium hydroxide gives me sodium chloride and water. And so acid-base neutralization reactions are considered like this. You take acid with a base and you form a salt. And salts are ionic compounds. They just don't have to be sodium chloride and water. Okay, so that's why this picture is like this. So let's do another. So we're going to take phosphoric acid, combine it with calcium hydroxide, and what we want to do is get the word equation, the chemical equation, and the balanced chemical equation. So change the phosphoric acid to its ionic name, hydrogen phosphate. Calcium hydroxide, then swap them. Okay, so the hydrogen goes with the hydroxide, and the calcium goes with the phosphate, and you get that. So write the initial chemical equation. So H3PO4. So it's H plus, 3 of them, PO4, 3 minus. Calcium hydroxide is Ca2 plus OH. Then you need crisscross charges. Calcium phosphate is Ca2 plus, phosphates PO4, 3 minus, crisscross charges, and you get Ca3PO4, 2. And then HOH, which is water. Okay, so this is the unbalanced or the initial chemical equation. Now let's balance. Okay, so again, what I'm going to do is I'm going to start out with one of negative ions, and I start out to one that has the most. So there's 2 of the phosphate, so I'm going to put a 2 in front of here. Now what I do is I count the number of hydrogens, and that's 2 times 3 is 6. And notice now that I have 6 OHs, so I put a 3 in front of the calcium for 3 times 2. And then I notice is that the calciums are okay and I'm balanced. Okay, and I'll write up, do this like I do it in my class. Okay, so let's show you how we do this when I show my class. So you can actually start, so you have 2 negative ions and there's the same amount. There's 2 OHs and 2 PO4s. It doesn't matter which one you start. I usually like to start out with the substance that has the most subscripts. So I know there's 2 of these, but there's 3 of these, so I like to start out with this one. So first thing I need to do is I need to have 2 phosphates. So I'll come over here and give myself 2 phosphates. So 2. Okay, next thing I need to do is fix my hydrogens. So 2 times 3 is 6. It's 6 H's, and it's this H here. It's not this H with the hydroxide. So I put a 6 here. All right, next step, notice is now I have 6 OHs. So third step, I need 6 OHs. And I have, so what times 2 is 6? 3. Okay, and then finally I check my calciums. I need 3 calciums. And done. All right, and there. All right, so that was it. So let's go over what you need to do and what's going to go forward from here. All right. So so we talked. So there were three types of chemical reaction. First one was combustion, and what you need to do is if I give you alkane, you're going to have to finish the word equation. That's simply going to be the alkane plus oxygen, but gives me carbon dioxide. And sorry about my writing. And water. Okay. Okay, it's that simple. Oh, then write out the equation. So you write out the alkane plus O2 gives me CO2 and H2O. Then balance equation, the method I told you. Then what you need to tell me is why this chemical reaction takes place. Remember, it has to do with oxygen being hungry. And then what is oxidation reduction? Okay, single replacement reactions, there are 2 types. There's metal and ionic, and what I'll do on the test, give you the reactants, the name of the reactants. You just finish the word equation. I'll write out the initial chemical equation and balance it, and tell me what's being oxidized and reduced. Also, I want you to be able to tell me what a solution is, the parts, solute, solvent, and how you do it, and what happens to the metal, and so what happens to the metals chemically and physically. Right. The second type was metal plus acid, and again, give you the reactants and the words. Finish the word equation. Remember, change the acid to ionic names. Write the initial and the balance equation. Tell me what's being oxidized and reduced. Uh, all right, explain to me what happens to an ionic compound when you put it in water and an acid when you put it in water. Explain to me what acid is and what happens to the metal and hydrogen chemically and physically. And finally, with double replacement reactions, there are two types. Oops. There's precipitation reactions. We take two substances that have been dissolved in water and are solutions, and you mix them and you form a precipitate. I'll give you the starting. You'll have to give the initial, finish the word equation. Remember, change and change word equation, then write the initial and balance equation, and to also tell me why these reactions take place. For acid-base neutralization reactions, same thing. I'll give you the reactants and words. You finish them off. You want to change the acid to ionic name, write the initial and balance equation, and tell me why these reactions take place. And finally, this sounds a little overwhelming, so you're going to need practice, and I'm sending out worksheets that will hopefully have you practice with this. Okay. I suspect that this test will be maybe the week of June 22nd sometime, but we'll see how things go.